Okay, Assalamualaikum and good morning. Okay, so today we will enter the last topic, which is chapter 9, chi-square test and non-parametric test. But for this video, we focus on chi-square test. Okay, in chi-square test, we have two types of categorical variable. First, you will learn goodness of fit test, and second is contingency. Table analysis. Okay, so chi-square test is a non-parametric test, also called as a distribution-free test. Because this test that we don't have to assume the distribution follow a specific distribution. So basically for parametric test, we need to assume that distribution is follow normal distribution, but for non-parametric test, all of the test is distribution free test, meaning that you don't have to assume that distribution is follow specific distribution. Okay, so for chi-square test, basically it's involved with the categorical variable. Okay, so we already learned in chapter 1, which is level of measurement. It starts from nominal, ordinal, and then level interval scale, and the last one is ratio. Okay, so basically for parametric test, we need to assume that the data must be at least interval scale. Okay, then you can use the data to solve parametric test. But for non-parametric test, basically the data is nominal and ordinal, which is this one is involved with categorical variable. Okay, so for categorical, actually first the characteristic is first is finite category. Okay, second is name or label, which is this one is qualitative. So some of this one we can categorize as a nominal or ordinal. Okay, so basically for nominal, it's involved with the gender, and then ordinal is involved with the rank or satisfaction. So this one is also in ordinal. Okay. So for non-parametric test, basically the data is nominal and also ordinal. Only these two type of measurement that we use in non-parametric test. Okay. So let's take a look. For chi-square distribution, okay, chi-square distribution is often denoted by the chi-square distribution. So chi-square, actually this one is from Greek letter, which is lowercase of chi. Okay, so this one we call as a chi-square test. Okay, the chi-square distribution is a continuous probability distribution that is widely used in statistical inference. It is related to the standard normal distribution. Actually, if you see the degree of freedom is increased, so actually you can see the distribution is follow normal distribution. Okay, so later we will see the next slides. Okay, if this one is a theorem for chi-square distribution. If a random variable z has the standard normal distribution, then z power of 2 has the chi-square distribution with 1 degree of freedom. Okay, so basically if your random variable is standard deviation, then z power of 2 has the chi-square distribution with 1 degree of freedom. Okay, so if our degree of freedom is 1, so the distribution is like this. Okay, this one is our we call as a chi-square distribution with 1 degree of freedom. Okay, if Z1, Z2 until Zk are independent standard normal variable, then Z1 power of 2 plus Z2 power of 2 plus until Zk square has a chi-square distribution with k degree of freedom. So it's depend on the value of this one lah. Okay, how many k? So this one is degree of freedom for chi-square distribution. The probability density function of the chi-square distribution with k degree of freedom is given by this one. This is the function, probability density function for chi-square distribution for x is greater and equal to 0. This one is our second theorem. Okay, the mean of chi-square distribution is mean equal to k, meaning that the number of degree of freedom is equal to the mean distribution. If our degree of freedom is 4, meaning that our mean also 4. Okay, while the variance is 2k. Okay, so for 2k, if our degree of freedom is 4, meaning that our variance is 8. Okay, so it's depend on the value of degree of freedom to find the mean and also variance. Okay, so this one, if you can see here, the degree of freedom increases, the chi-square distribution looks like a normal distribution. Okay, so this one, if degree of freedom is equal to 1, means that your mean also 1. So the distribution is like this. But if the degree of freedom is increases, so you can see that the distribution is look like a normal distribution. Okay, so as the degree of freedom of the chi-square distribution increases, the right skewness of the distribution decreases and the distribution becomes more symmetrical. Okay, the mode of the chi-square distribution is equal to k minus 2. Okay, so for example, this is your mean, your degree of freedom. So degree of freedom is 15. Okay, so same also with your mean, because mean equal to k, so mean also 15. Okay, and then to find mode, so you need to k minus 2. So 15 minus 2 is 13. So this is your mode for this distribution. Okay, chi-square statistic. The chi-square statistic for a random sample of size n with a standard deviation s selected from a normal population having a standard deviation sigma can be calculated using the following equation. Okay, so basically if you see that the question involved with standard deviation and also standard deviation for sample and also standard deviation for population, so you can follow this equation. Okay, just substitute the value and then you will get the value of chi-square. Okay, and then cumulative. Okay, if I mention for cumulative, basically for this one, your symbol should be less than and equal. This one is also similar with the other distribution. Okay, if they mention above cumulative, meaning that your symbol should be less than and equal. But if the question wants greater, so means that you need to 1 minus. Okay, and then you need to exchange the symbol, which is less than and equal. Okay, because for cumulative the symbol should be less than and equal. Okay, it's very important. Okay, now the chi-square distribution is constructed so that the total area under the curve is equal to 1. Okay, so all the distribution have the probability area under the curve is equal to 1. The area under the curve between 0 and a particular chi-square value is a cumulative probability associated with the chi-square value. The cumulative probability associated with a particular chi-square statistic can be easily determined using a chi-square table.